So I'm going to talk about the C++ project problem. And then after I talk about it, I'm gonna study CLang's source code. The problem is related to, I still haven't figured out font rendering, which is really annoying to solve. So I'm still trying to render the fonts, but as I was trying to render the fonts, I got into this problem. And then I want to recommend this Discord server here because I've been posting questions there more often now, and there are some really helpful people there, so I really recommend. But basically, the issue that I was having, so I'm trying to render text on the screen on OpenGL, and I was trying to do it based on NanoVG, which is a library that renders GUI elements. This library here. And then they use another library called PhoneStash, and I got the header file for PhoneStash from this repository here. And this PhoneStash header, it has a bunch of function definitions. It has both the declarations and the definitions. And I was trying to create a class based on, so I tested another project actually, now that I remember, which is GLText, which is another GitHub repository. I think maybe I should just open here. And then it was working fine with this project, but I wanted to translate everything to a class, and then when I did that, it wasn't working for some reason. And the problem with this one is that they render text, they get the data directly, and that's not the best way. The best way is to read the file first. You read the file, then translate all the data from the file, and then you cache in a, not cache, you translate the data from the file into a struct, C++ struct. And then based on the C++ struct, you call the OpenGL functions, and then you create the image that is based on the file. So that's the way that they do it. And I was trying to study NanoVG and then use the functions from NanoVG to incorporate on this one and create a class to render text. But then the issue that I got into is that I was including the header for PhoneStash on this header file here, and then I was including this header file on label CPP and on this one. I'm not going to be able to show now because I'm changing this project now, because I'm reusing another version of this PhoneStash library that someone on the Discord server that I recommended, they recommended this other version, and it seems that this other version separates the definitions from the declarations, so it seems to be better, and also it's a lot simpler from what I've seen, but it's still not working for some reason, so I'm gonna have to figure that out. But pretty much that was the error that I was getting, is that even though I was using the header guards here, I was including this header file both on this CPP file and on this one. And when you do that, what happens on C++ is that it has something called translation units, which is just a fancy way to say source code or source file. So all the CPP files and the headers that the CPP files include is a translation unit on C++. So when you have different headers on different translation units, the header guard doesn't prevent the header from being included twice. And the problem with that is that if the header file has definitions, then there's going to be a conflict between definitions because you're going to have two different definitions. And the reason why this happens is because of the steps on the compilation process. So first you have the preprocessing, which replaces the macros you have on the C++ files. And then, so it's just copy pasting the code. Instead of having the macro, it's going to place whatever code the macro defines. So for example, if you have this macro here, across the file is just going to replace the name of the macro with whatever you define the value to be. And then that's going to be the final C++ file on the compilation step. And then on the compilation step, the compiler is not aware of the whole project. It compiles one C++ file at a time. And then after it compiles everything, it turns every CPP file into an object file. Then the linker is going to link all those files together. So it's going to find the definitions for the declarations. And this is the problem, is that the compiler is not aware of all the files simultaneously. So if you only have one translation unit, then putting the guards here work, because the compiler is gonna know because it's in the same C++ file. But if you have the header on multiple C++ files, then the compiler is not gonna know, and then the linker is gonna give you an issue because the definitions were done twice. And this is the issue that I really don't like this. So what I was thinking about is, why is it this way? And it doesn't make a lot of sense to me. So based on like little research that I did, it seems that the reason why is because C++ is an old language, and they made things based off C, and because of backwards compatibility, it's very hard to change the way things are now. It seems that that's the problem. So one of the solutions that they came up with is to, I think the only solution is to add modules on C++20. So, and modules are more similar to the way that higher level languages work. But the thing that I don't like about this is that it seems like it only adds another stuff into the language, which makes it more confusing, I think. And it is a hard problem, so because of backwards compatibility. But what I think about is always trying to reduce the amount of stuff, not add other stuff on top of it. But obviously that's the whole challenge, because the more people we have building stuff with the language, the harder it becomes to make changes, and then because it's going to impact everyone that is in the language. But it really made me think that it is one of the parts of C++ that I really don't like, is that you have to include a bunch of headers and then you have to put all the declarations. It seems kind of redundant, and it just makes things a lot harder to understand on the overall project. So the conclusion that I got so far is that the biggest reason why it is the way that it is because of the separation of concerns along the toolchain. So because you have the preprocessor, have the compiler, and you have the linker, and they are limited to certain amounts of information, you can't really simplify this. But one thing that I was thinking about, and this is just one way that this is the reason why I'm gonna study CLang. One of the reasons, actually, because I already planned to do that, but now I'm planning to go a lot more in depth into it. But I'm not really sure though. Like I might change my mind. So, but for now, I think I'm gonna spend some time studying CLang as I try to solve the texting, because I want to understand. Like the main thing that I want to clarify is exactly what's the connection between the different steps of the compilation process. So I understand what kind of information each step of the process has. So the solution that I thought about is, if the preprocessor had access to the information of, or if you kept track of all the defines that it has on all the files, for example. So you can imagine, for example, you create another file, and then on this or another, it could be a buffer, a place in memory, where you keep track of all the guard headers here for every file. The preprocessor does that, and then it just creates a cache. And then based on the cache, the compiler would have access to that value, which would be a hash in the CPP file. So instead of whenever the preprocessor encounters a CPP file that has a guard header, so in this example would be label HPP, instead of putting the source code for all the functions, you would put a hash that would work as an ID if the header was already included in another C++ file. And if that was the case, then you would have only one file containing, which would be the first one that the preprocessor encounters. It would be only one file responsible for getting the definitions for all the functions. So as long as the same file on multiple different C++ files, then it would probably work. But then one of the issues would be that if the preprocessor is not linear, if it doesn't go file by file, but it's in parallel, Then obviously you can't do that because you don't know, but then it just adds another step of logic that you can put everything into a queue or something like that, and then you can do some logic later that is gonna figure out uh, what are the unique headers and if there's conflicts and stuff like that, and then you would just cache everything and the compiler would have access to that information, and then you wouldn't even be necessary to have a bunch of declarations. You can do a hash based on the function definition as well. So instead of having to declare the function, you can just put, for example, the name of the return type, the name of the function, the return type of the arguments, and the name of the arguments. And you can turn that into a string and then can map that to the function definition, to the place in memory that the function definition is at. So, and that way I think it would be a lot better. So I'm not really sure if it's going to be worth it to dive too deep into this, but it got me curious about understanding CLang, which is one of open source implementation of C++ compiler, which comes from LLVM, which is the project that I'm going to study. So CLang is the front end, which is just the syntax analysis, and then LLVM is the back end, which is the machine code interpretation. So, and I'm not really sure. I'm probably not going to go very far today because it's extremely complex. So yeah, but I want to study the source code. Your C++ standards have some really dubious features. They're competing to see how much useless stuff they can fit into standard lib. Diving into CLang's source is honorable, but not quite necessary to understand the full compilation process. You might want to look into manually using compilers via command line keyword. Yeah, I'm not interested in that. I want to understand like the nuances in the fundamental. I was thinking about. I'm going to study all these things at some point anyway. So I thought that now, because of I'm curious about this, is like a good time to. It's just going to be a surface look. I'm not obviously not going to. I don't assume I'm going to understand everything, but I just want to see like what kind of files they have here and at what point do they do certain things. How does it work? Just trying to clarify more. But I want to understand from fundamental first principles how everything works. Oh, the other thing that I realized is that it's better to just put the files on the right side here. I don't know why I didn't think about. I think that this should be the default for VS Code. I don't know why it's not the default format, because it's obviously it makes a lot more sense because then like the code is on the left and then you have to decrease the size of this less often because it's easier to see where the limit of the line is gonna be. So I'll take my leave. Oh, thank you. Thank you, man. The hard part, as always, is gonna be the beginning to understand everything. So this is the reason why I think that I'm gonna do both these things simultaneously. So I'm gonna do a little bit of studying the CLang's thing. I'm probably gonna watch a bunch of videos that I already have here and read the documentation and all that stuff. But as I do the text rendering thing, because text rendering is very annoying as well with OpenGL. I'm getting some issue now that's it doesn't have one of the operations is wrong, but I'm not really sure why. So I was reading this documentation here from CLang. I'm gonna go to the GitHub project. I don't think that because this is the thing is that LLVM, as far as I understand, is not specifically for CLang. It's just a more generic thing that allows you, is a backend. So the way that it works, the way the compilation process works, as far as I understand right now, is that you have the front end, which is the syntax analysis, which is you're just gonna take a string input, and then based on rule sets that you call the grammar, you're gonna have the words of the grammar and the rule sets that make up phrases. So the first step is gonna be to create the Lex tokens, which are gonna be just parsing the string and getting the words from the string. Then after you do that, you put them on an abstract syntax tree, which is just a connection of the words based on the rule sets of the grammar that is going to generate meaning from the phrases. Then after you do that, you create then is that it's gonna be there's gonna be a lot of nuances because it's gonna depend on the language and a bunch of optimizations that they do to make the execution faster, obviously. But usually the way that it's going to work is that you're going to translate the language from the abstract syntax tree into either an intermediate representation or assembly representation of the language. So it's just a lower level, let's say, way of describing things that is, and as far as I understand, the reason why they do it like this is because there is a standard based on the hardware of the base languages, let's say, which is the assembly language that is directly connected with the hardware. So obviously it needs to have a standard because if it doesn't if it didn't have a standard, then you can't compile anything because it wouldn't know how to communicate directly with the hardware. So the backend process is taking the abstract syntax tree or whatever representation I have after parsing the string and creating the data structure that is going to represent the grammar for the string. It's going to take that and it's going to transform into the lowest level representation that the hardware can understand. And then after it does that, it's gonna use. I'm not really sure if LLVM uses another program, but from the example I was studying some time ago, use another program called NAS, which is an assembler, which is just gonna take that thing and take the assembly language and transform into machine code, and that's gonna be the executable. So I assume that on C++, there's gonna be the other steps, which is the linking and the preprocessor. So I'm not really sure how they work here. So the first thing that I want to understand is what's the point of the what is the entry point of this thing? That's the hard part. But I think I'm not going to be able to just understand it from here. I think that they use another. So the CLang is the front end and the LLVM is the back end. So I'm not sure if it's better to start from LLVM and then try to go into CLang. Maybe I should just search for keywords and then try to find the files. One thing that I'm probably gonna do is the control flow, but I'm not really sure if I'm gonna do that now. To make it easier to understand how everything connects. Let me just search for. Oh, there's another thing that's some of the. I guess this is kind of what LLVM does, but for the backend. But Python, for example, uses a parser generator, which is just a program that you code. There's going to be a more generic way of translating the grammar into an abstract syntax tree. So it's kind of like meta programming, where you have a program that's going to change the nature of the code. So you're just using the program to, based on the grammar rules, you create a bunch of functions that are going to represent, or are going to allow you to have the logic to translate string input into the abstract or a parse tree, and then later on abstract syntax tree. So I'm not really sure. I think it's probably easier to just go into the Lexer files first, and then because I'm not really sure how to. Maybe they have something called AST or abstract something. Probably these ones are easier. I might have to go over the LLVM stuff first, though. The thing is, I didn't read all the documentation, so I assume that they have something somewhere that explains. Probably the thing that I was reading here explains how everything is structured. And if I go to this one, oh, there's a maybe I should spend 1 hour on this and then another hour. I think I'm just gonna spend like I was gonna say 1 hour on this and 1 hour to try to solve the issue on the other one, but probably it's better to try to solve that off stream and then just focus on this. Maybe I'm gonna do 2 hours, and maybe off stream I'll try to solve the other stuff. This provides a simple interface that turns a text buffer into a string of tokens. This provides no support for file. I already understand a little bit how it works from other languages. I think it's even easier to parse C++ and C because it's statically typed, so we don't have to resolve what kind of type each thing is. It's probably harder to. I remember studying uh, there's a book. I don't remember the name very well. I think it's guides to interpreters or something like that, and they explain. Uh, they create a parser for a high level language, but I don't remember really well how they resolve the types. Create pragma lexer, lexer constructor, create a new lexer object for pragma expansion. This has a variety of magic semantics that this method sets up. It returns a new lexer that must be deleted when done. So it looks like there's a bunch of constructor overloads here. Source file location or file ID. Lexer object for the specified buffer with the specified preprocessor. Preprocessor managing the lexing process. This lexer assumes that the associated file buffer and preprocessor objects will outlive it, so it doesn't take ownership of either of them. Hmm. So this is probably where they do the preprocessing. You know, dance with the lexer to efficiently preprocess tokens. I'm not sure if there is a language that is just like C++ but without the headers as well. I was thinking about this, but I think I think Rust is not the same thing. So it's very different probably from. I'm not 100% sure, but I think it's different. I was wondering if there is a because I was thinking about like is it worth it to try to just change everything to because one of the reason why is probably the reason why I think it is the way that it is, probably the main reason why, is because it's extremely difficult to change things and maintain backwards compatibility. I think that's the reason why it's very hard. So, like, I haven't seen much from the modules part, but based on what I've seen, it seems that I don't like it that much because it seems that it is a duct tape solution. So, like, usually for me, the direction that is probably the best is to try to remove as many things as possible and not add a bunch of stuff. So that's how it feels like, anyways. I could be wrong, but yeah. So it feels like the best solution would probably be to try to change the compilation process so that, or the toolchain pipeline, so that the so that we don't need headers or other stuff like that instead of adding the modules thing. but then obviously breaks everything. So I was thinking about whether or not it's worth it to try to just change it to create another language that is going to be the same as C++ but without the headers. But I'm not really sure if I have time for doing this stuff because it's probably very hard as well. I do want to understand though. Include stack. This is another thing that is great about doing this is that you find like different data types that they use and different stuff that might be useful to search. The other thing that I was thinking about making another language is that the reason why it's going to be hard is because of CMake. So if you do another language that is just like C++ without the headers, and I was thinking about like having something that has Python or JavaScript import systems, but has the C++ language. But I'm not really sure if that's worth it. And the other thing is going to be the build system. And I think that the issue with building something like CMake is that it's probably really hard because of the dependencies of dependencies. So, and this is another problem that I think everyone talks about JavaScript, but it's that thing is probably something more fundamental because it's related to the variance of data and the whole ecosystem and the infrastructure from which code is built. So I think the reason why Node modules is the way that it is because of culture and the way that code evolves and everything works. So you can't really avoid that, I think. And it is a very difficult problem because then, like, if you have a project that has a dependency and that dependency has other dependencies, then how do you resolve all the imports and all the stuff like that? It seems like this is something very hard to think about. This is another main thing that I'm interested on is the symbols, understanding how, because I'm not really sure if my intuition is correct. So the way that I think it works, based on the stuff that I've seen as well, is that you have this symbol table is going to be used both on the lexer and the parser and on the other phases of the compilation process. So what usually people are going to do, they're just going to create a table or a table, maybe a hash or linked list of tables. And each table is going to have a symbol and then it's going to have some information about scope and file or something like that. And then I think mainly for resolving scope, that's what I've seen. That you traverse the linked list with the scopes and in check to see on the cache of the symbols if the symbol already exists or not. And that's how you figure out the collisions of variables and other stuff like that. So I assume that they are doing something similar to figure out what are what is the relationship, what functions were declared, where were they defined, and what is the relationship of everything. But it's kind of confusing because of the separation of the preprocessor and the compilation. One of these records is kept for each identifier that is lax. This contains information about whether the token was defined, is a language keyword, or if it is a front-end token of some sort, a variable, a function, or function name. Preprocessor keeps this information in a set, and all talk identifier tokens have a pointer to one of these talk identifier tokens. But probably I should, so yeah, I should create another one of these step files here, or information. I'm gonna do it from here because I can use the special arrow that they do it here. I'm gonna write down some of the keywords. So the idea that I have is just to, this is the thing I'm not really sure because the thing that I'm building is probably gonna help me understand this faster. There's always a balancing thing, so yeah, I think just for, I'm just gonna do the very basics. Just gonna write some stuff that I find there on sort of like keywords and the general thing, and then I'm gonna try to. This I'm not 100% sure, but because I might just focus on the text again and then try to advance on the other projects more instead of focusing the attention here, but I'm going to try to create a flowchart that connects everything and understand what is the, probably the videos will help a lot as well, and the documentation. Where is this thing? Maybe info. Yeah, another thing that I'm trying to understand is the main connection between C++ and Python and JavaScript. What is the difference? Why does Python, and this is something that I didn't figure out. So I assume that probably happens on the last steps on the backend of how, why Python doesn't need declarations and why C++ has declarations. I remember it was very hard for me to understand as well. How is it possible that the compiler is written in the same language that the language is, like, is a chicken and egg kind of thing? So how is it possible that CLang is written in C++? And the reason why is because everything compiles down to uh, combinatorial logic, which is just fixed logic on a EEPROM, which is a device that allows you to set a specific state and map that into a symbol. So you just set a truth table based on transistors of what the symbol is going to be, and that allows you to encode the information of the symbol. And because the EEPROM is connected to every part of the computer, it allows you to just put the logic of the coordination between the different systems as information inside the combinatorial logic. So the way that I think about it is that combinatorial logic is more fixed. It's a fixed state based on the transistors that is going to create this gate. It's not really a gate, but it's like a collection of gates that holds a state of information. And that state's going to determine how every component of the computer is connected to each other. And it's also going to allow you to create a symbol that represents that. And the symbol is just an abstract idea that comes from human beings, obviously. So you can connect the symbol of A to an impulse that is going to represent what the computer does. And because you can do that, because everything at the base is a fixed state, let's say, then you can use those fixed states to create more information that is going to allow you to encode the rules, and it closes the loop like that. So you encode the rules using the fixed symbols because you can combine them in different orders. So all that is happening is that you're changing the sequence of causes and effects of the different fixed states that you set on the hardware. And then based on how the sequence changes the fluctuation of the state of the hardware, you're gonna change you can encode the information to put the rule set that is gonna determine how an abstract idea is gonna transform into a sequence of impulses. Because you're just building abstract meaning, like a symbolic representation based on the connection of causes and effects from static representations of impulses. So I couldn't find the function there, I think. This declaration is kind of weird to me. So this is why I was thinking about here. I guess this is gonna be 8, which is the enum here. So I'm not really sure. If it was an initial array list, would have the 2 dots here. So I don't know. Maybe this is something. No, a macro. No, it's kind of weird. Well, this records is count, blah blah blah. So I'm gonna write this down, and then I wanna find the stuff that is related to preprocessing. So clarify the connection between the preprocessor and the compilation process. And later on, I'm gonna go back to studying Python again. So I'm gonna merge the two. I'm gonna clarify like what was the transition between using header files and then using the just the import statements. And that's kind of the confusing thing. It goes back to this thing about the language compiling itself. Is that the transition between the languages is kind of weird because the main implementation of Python is CPython, which is written in C, obviously. So it makes it kind of confusing because when I think about Python now, I'm thinking about the C source code of the compiler and how it's structured. So even though Python itself doesn't use declarations, C uses declarations. So it's kind of like using declarations by proxy. So it's unclear to me if it's possible to. But then you can create the compiler on Python and goes back to what I was saying. So it's kind of confusing to understand. It needs a line to 8 bytes because the declaration name needs the lower 3 bytes. Hmm. Not sure what this means. I'm gonna ask ChatGPT about this. But I assume that it is something related to structs, like the same concept of structs, where you can pack, like you're incentivized to pack the information inside of the structs because of the way that the memory works. So I think it's something similar that they are doing here. They're putting this 8 to signal that should create a word to maximize the efficiency on the memory space. But I don't understand very well how it works. So I'm just gonna paste this on ChatGPT. I need to review friend functions as well. Friends, a friend, whatever you put here. But I think I'm gonna ask ChatGPT again. But it's something to do with the access. It allows another classes to have access to protected member variables or something like that. Oh, did I put some stuff? Contents of the code snippet, you provided the phrase, it is aligned to 8 bytes. Specific alignment requirement for the class identifier info. Declaration name, assume that is the name of the class. That's whatever. We're just gonna move on to other things. I don't think you can find just by searching for our main. It's just a bunch of text files. Maybe this is the only one that is not text. Okay, fix revision name. Hmm. Oh, this is another language, I think. Oh, should be the same project. Oh, this is another one. Yeah. So this is probably a Fortran implementation based on all of them. So it's not related. Rules driver. Here it is. I think that's probably better. So I'm gonna close the other files. Just gonna follow the execution from this file here. It's gonna take a long ass time to understand everything. So I think the best thing to do in the beginning is just try to, because otherwise, if I look into the classes definitions, it's just gonna be too loose. I'm not gonna be able to understand. I obviously understand the process, the concepts, but I wanna understand what is the flow of execution. I assume this is gonna be one one version. So I think it depends on what hardware you're using, probably. It has to be, obviously. Not obviously because you could have the logic. It's just the separation of logic. So you could have, instead of having three different files to handle different operations, different hardware and operation systems, you could have just one function and then handle inside of the function. This is the entry point to the CLang driver. Here's the thin wrapper. Be right back. That's another thing that I didn't. I thought about, but not the like on the code itself. Was that the connection of CLang with CMake? But I think the reason why I didn't think about this is because it isn't necessary. It seems that it is a thing, but it's not necessary for CLang to have some code that is gonna uh, be interact with CMake, because you could just have the code for CMake to just have some condition that based on whatever condition is gonna choose the compiler and then just runs the executable. So like the CMake process is separate from the compilation. So that they are is different than I was thinking about. So the driver is the thing that driver file is gonna be the logic that parses command line arguments. And I think that it's just gonna be so like the difference between different operational systems is probably just gonna be on if-else statements across the entire project. So as but there's probably something related to different. It has to be something related to different hardwares because that's the only way to get the machine codes for the hardware. From assembly, I think that the way that it works is just that So this is something that is not very clear to me now, but I think that because it would be impossible for anyone to memorize the names of everything that happens inside of the hardware, I assume, because there's gonna probably like billions of different memory, different registers, different memory processes, let's say, or like inside of the hardware is probably very complex, exactly what is going on. But I think what happens is that even though everything is complex, everything is just run by the same names. So you attach the concept into the whole, like a bunch of complexity. So even though there's a bunch, so for example, register, like you can have the concept of registers and then you have billions of registers, but they are all doing similar things, like it's the same thing. So I think that's how it works on assembly. So we have names for specific registers, but it doesn't mean that it's just one register on the computer. It's just like the type of register. And then from those types of registers, everything happens. And then you have the arithmetic logic unit, which does the calculations and the other parts as well. And then assembly, or the intermediate representation, is going to access those concepts. And that's what everything is going to be boiled down to, I think. So probably the symbol resolution is the most interesting for me now. It's both the symbol resolution and metaprogramming as well that I'm trying to clarify. How does it work on metaprogramming? Blah blah. So I'm gonna write this down as well. Obviously, I'm not gonna take at face value, but I'm gonna see if that's the case. I'm gonna write down what each file is related to, so I can see. I think this one is the most interesting now, obviously, because it's related to stuff that I already know. So I'm gonna see if I can understand the beginning of the lexing. One of those functions that I was seeing is probably the one that's. So I was looking at the lexer class. That's probably the thing that has the function that's going to receive the file inputs, and it has to be connected with the driver thing. If the driver is the thing that parses the command line arguments, and then from that point, it's probably gonna open the file and then just read the characters. So another question is whether or not I'm gonna ask this one next, whether or not C++, they need to keep track of the, how does that work on the grammar? How C++ handles the grammar? Is it on the functions directly, or do they have something like Python, have a grammar or a parser generator responsible for? I'll close this one. Point for CLang assembler. I want to start by the CC1 main. It's probably this function here. As far as I understand, CLang is just for Linux as well. I just remember that CLang, CLang is for Linux and Visual Studio Code is for Windows. Or maybe not. Also works for everything. I guess the default on Windows is just Visual Studio, but you can use CLang. I was also gonna ask something that I just forgot. I was just talking about, but I forgot. Oh, the grammar. So it has its own handwritten recursive descent parser. Lib parser. Hmm. I think the preprocessor has to happen before, but so it happens between the lexical analysis and the parse tree, the abstract syntax tree. So it looks like this is a class that is gonna have the handle the state for the completion process. I think all programs are pretty much the same. Everything works the same way. So you're always gonna have data structures that keep track of data that is changing across the program. And then what changes is the flow of execution and the encapsulation of the flow of execution. I don't know if this is related to the includes or only the modules from C++20. So this is what I mean that it's kind of annoying from having to separate. So one of the positive sides of separating to header and source files is that it becomes a lot easier once you have a bunch of functions on a bunch of files to see what exactly does a source code file do. But it's still, I don't think it's worth it. It feels much better to me to just have the source files. Let me see if I can. It's not gonna work like this. So include CLang lux. Yeah, I'm not really sure where the source code for this file is at. If I ask ChatGPT, it's gonna. CLang basic. If I search for the names of the, or maybe it's not worth it. You just keep going. Because this is an abstract class, so it doesn't have definitions probably. So yeah, the functions that are defined here, the other ones are abstract. So yeah, this is probably the only. Uh, it doesn't have a source file because of that. But so I guess the constructor doesn't do anything unless you. No, this is the so you overload the this structure, and whenever you have this virtual here on the class, it means that the classes that are going to inherit from this class have to implement the function. So it's obviously this is going to be the class relationship preprocessing. This was the one that I was looking at, I think, from the lecture as well. Tokens within a single source file and don't know about anything about preprocessor level issues, like the include stack. I have to review this stuff as well. I don't really know what's the difference between this thing and lambdas, but I know it's used to create functions. The project that was uh, a translation of 3JS into C++ used this standard function, but I don't remember really well how it works. So you store callable objects. So this is probably, I assume based on the name, is going to be something that happens, or going to be a function that is going to be triggered whenever you add the token, whenever you get the token from the string. I remember a video from Jason that he talks about this, where, but I don't remember in which context, but it seems like this is the place where they do this. And he said that you should avoid using or declaring variables that have double underscore before the variable because the compilers use that. So I think that this is the part where they use this is inside of the preprocessor where they're gonna keep some information based on the parsing. It's probably better to just go back to the main thing and then try to follow the execution. I just want to see, like, get a general idea of what the classes and structs are gonna have. But it's probably more interesting to go to the pipeline or to follow the execution here and then try to understand at what point do they start parsing the thing. I done this multiple times now where like studying difficult or large projects and it's always like this on the beginning where it's very confusing first because there's so many things but then over time like once you get more and more used to it you stop having to think about different variables because you already remember what they are and then it becomes easier and easier to understand how everything's connected. So it takes some time usually in the beginning. I think this is something that discourages a lot of people because, and myself too, like I think it's just a human thing, especially because the way you are wired. So like we tend to think, so I don't remember which person said that, but I remember that a person said that, that usually we overestimate how much you can do in a year and underestimate how much you can do in 10. So it's kind of the same thing where when you look at a very difficult, challenging project, you tend to think about the whole thing at once, and then you end up not doing anything ever because like it's too much. But if you break it down into the smallest step possible, then it starts to become doable, and then you just get like the more times you go into the cycle, you have the reference in your mind of how it was in the beginning and how it was when you finished, and then it becomes easier and easier. It's like a virtuous cycle. I think that's probably the best approach in anything. Hey, hey, James, what's up? So you just break it down and then break it down into smaller things and then try to figure out the smaller steps first. This is not that interesting. Represents. The thing is, probably I'm gonna see if I can understand this from the other code, but obviously this is gonna be related to if that is the entry point, then the argv is gonna be the arguments that you pass. So I kind of have to understand this. It's probably gonna so it's using a bunch of functions. Then inside of the functions, they're gonna break down the like parse the string and then get the information probably. Where ref represents a constant reference to an array, zero or more elements consecutively in memory. It's a reference to an array. Start pointer and a length. It allows various APIs to take consecutive elements easily and conveniently. Not on the underlying data, it is expected to be used in situations where the data resides in some other buffer. Its lifetime extends past that of the array graph. For this reason, it is not in general safe to store copyable. Not really sure why they're doing this. Ask ChatGPT again. Something that I want to understand as well is why they do this. It is something that I haven't seen on C++ on the other projects that I've seen. Like it seems like there is two different names here. Like two different declarations of the names. Kind of weird. The node discard that just tells the compiler to not discard as SAS. I also have to review this because I don't remember really well, like what is the purpose of doing this. I think that the purpose of doing this is that when the thing goes out of scope, the garbage collector, it doesn't have garbage collector, but like it's not gonna be destroyed. So yeah, I think C++ doesn't have garbage collector, but so for example, the place that I vaguely remember seeing this was on the other project that translates 3JS into C++, and he was doing the nodes card on a function that initializes a variable inside of the function. So I assume that the reason why he was doing like that is because another thing that I've seen some time ago, that if you initialize a pointer, for example, inside of a function, then when the function stops executing, the pointer is going to become a null pointer because the function goes out of stack. So the place in memory that the pointer points to doesn't exist anymore. But then if you use no discard, I think that's it tells the compiler to not to keep that memory address for the thing. But this is not true if you use something on the heap. So if you use something with new or a unique pointer or sharp pointer, then it's automatically gonna put that thing on the heap. So the thing still exists after the function execution. I think that ChatGPT is not gonna give me a satisfying answer for this thing here. It's used to represent a reference to an array or sequence of objects. It is typically used when passing arrays or sequences of objects as arguments to functions, methods, or constructor. But it's a convenient and efficient way to work with arrays without the need for explicit pointers and size parameters. Context of the sequence, blah, blah, blah. So actually receive an array of sequence of objects of a specific type as an argument. Takes an array ref of constant C-style strings. It allows CC1 main to receive and work with an array of command line elements. But I don't understand. What is the point? I guess it's just a preference on the structure of the thing. Because usually the way that you're gonna do it, I think, I'm not trying, I don't remember really well on the other programs that I've seen, but it's usually gonna be a const char, and this creates a pointer, which is gonna be the beginning of a string, which is an array. And then based on that, you parse. So it's probably just a convenient way to create multiple different pointers to strings that is has more information on each thing that is passed through the command line. In case the return value of the function should not be discarded, meaning that the return, yeah, that's what I was saying. So confused with garbage collections, but yeah, obviously C++, yeah, both C++ and C don't have garbage collection. We have to manually delete things, but it's kind of it's similar, but it's not really the same concept. So I guess you could say that. So I'm gonna ask this to ChatGPT. I guess it's different because it is on the stack. So everything that is on the stack automatically is gonna stop existing once the function finishes executing. I guess that's the difference. In garbage collection, it should remove the stuff on the heap. Yeah, that's what I was saying. So let me just keep going on. I'm gonna take a brief. It's just not that interesting. Well, this is another thing that I'm curious about is understanding what is the 'cause I don't know when there was something related to this that I searched at some point. I think it was when I was trying to solve something related to a dynamic linked library, and based on some stuff that I've seen, it seems that there are default paths that the I'm not really sure if CLang looks for them or if it's other all compilers look for them, but I think that there are standard paths that the probably the compiler you're using is going to search for in the operational system to find the standard libraries and stuff related to that. And then if it doesn't find it, then it's going to throw an error or you have to specify. There's another thing that is confusing with the dynamic linked libraries. So I don't understand how exactly, and I think it's related to this thing here. CLang get header. So everything obviously is going to come from this, which is the stuff that is initialized in the beginning. As this is probably related to the backend part of the assembly or whatever language they use to create the machine code later. I'm gonna look into this one first again, just to remember. I think the other time I looked into the header is this. So this is probably gonna be from what I remember on the last time that I studied the compiler, which is a lot simpler than this, just one to teach. He used two different structs. One is the compilation. One struct kept track of the information of the whole compilation process. And then inside of that struct, there was another struct that kept track of the lexing and I think another one for the parsing. So I'm not really sure if it's similar here, but I assume that this one is probably the one that is the main one that is going to hold all the information for everything. So this one is probably, so this one definitely poses the AST. There's probably another one related to the lexer. Interesting. I think this is related to modules probably. From what I've seen from modules, I think you use the import and export keywords, but I don't remember very well. It could be related to includes, obviously. Describes a module import declaration which makes the contents of the named module visible in the current translation unit. Which makes the contents of the named module visible in the current translation unit. Contents of the... So I think that this is what I was talking about before. So probably the module is the stuff that I was thinking about. What I was thinking about is that the preprocessor keeps track of the include files and it hashes them. It creates a map that creates a unique string that's going to identify the header, and then it puts that on the C++ file. And then based on that, you can resolve. You can include can include headers in multiple different translation units and not have a conflict. So it seems like it is very similar to what I was saying. It's probably the same thing, but it happens on the compilation process. So when you declare a module, you're probably just doing like something similar to what I just said, where the compiler is gonna look at the module and then it's gonna figure out the definitions there. But I'm not really sure if that's gonna resolve the translation units thing. Based on this, it probably does. No, in the current translation units, it doesn't say for all translation units. An import declaration imports the names or submodule. So module import declaration imports the name module or partition. Periods are permitted in C++. Blah blah blah. Next, importing the list of imports local to the translation unit being parsed. Blah blah blah. And that's that interesting. The problem is that I don't have the context to understand how this is used, so it's returning new with no name here. It's just creating a place in the heap, I think. It's gonna return this time. So it returns a pointer to the place in memory that creates here. Yeah, whatever. It's kind of confusing the way that this is here because of this. Whatever. And it seems like there isn't any lax thing related here, unless I'm missing something. And this is something. I thought that this might be the pimple thing, which is the pointer implementation. It just creates a variable instead of the class that is going to be a pointer to the variable. And it's kind of confusing as well, but it allows you to not have to compile everything every time you change something. So like if you're developing a library, it kind of creates an interface between the library implementation and the thing they're going to use by creating a pointer variable inside of the class. I thought that this is something similar here, but I'm not really sure. I think that's probably not. This is just more like a parameters kind of thing, I think. And it depends on the options you pass on the command line. It's gonna create this thing here that handles the options. And then the functions are related, are from this thing. As invocations here. Let's see this. Header subtract. Helper class for storing options related to the initialization of the header search object. Oh, this is from the lax thing. I think I'm just gonna go back to the main implementation. I'll look at this first. This abstract interface provides operations for creating containers for serialized ASTs. Containers, precompiled headers, and CLang modules. I assume that AST consumer is going to be the thing that reads the AST, translates the AST into the other representation of the code. And this is related to parsing the information there. I'm gonna go back to the, just gonna make a unique pointer. Oh, so this is the thing that I was talking about, I think. But this is for abstract, it's probably something similar. So it is a pointer implementation, but it is on an abstract class. So when you inherit this, you create the pointer implementation through the function, I think. And this is for reading the inputs that the compiler receives. I'm not gonna spend too much time on this. I think I kind of get it, this thing here. And this one is I'm also curious about. It's probably gonna be related to the, obviously has to be related to the registers. And this is the thing that I was looking at, I think. Or something similar, container for abstract syntax tree consumer. Registry of PCH container writer and reader objects for different formats. This is the thing that I was looking at, I think, before. This abstract interface provides operations for containers, yeah, serialization of AST. let me remember. So this returns a pointer to this thing here. Pointer to this. And then this is going to contain register. So I guess this is the thing that consumes the abstract syntax tree. And then from the first video that I saw there from LLVM, I think that the way that they do it is they have an unlimited amount of registered names, and they generate the registered names on the fly, I think. So this is probably responsible for doing that, I think. Yeah, this is what's happening here. So they cache the registers on this thing here, and this function creates a register. So it maps this the writer format with this writer thing, which is probably something used to create registers later. And I think that LLVM it doesn't compile to assembly, it compiles to an intermediate representation. And this is going to be the thing for that I just looked at. So what is the writers? The writers is this thing. So there's a map of string map of unique pointers to this writer. This is an unconventional map that is specialized for handling keys that are strings, which are basically ranges of bytes. This does some funky memory allocation, hashing things to make it extremely efficient, storing the string data after the value in the map. Interesting. So I'm not 100% sure, but as far as I know, the way that the map works is that you have two different arrays, and then you just use a hash function to map the key with the other. So in one array, you store the keys, and then based on the key, you just implement a hash function, and then you have the location of the value on the other array, and then you get the data. So I think what they're doing here is just changing. So they are creating their own map to make it more efficient. And instead of doing that, they are storing everything on the same array, and then they just keep everything, the value right next to the key on the right, probably. And then it does some funky memory allocation because probably I'm not really sure if it's going to be dynamic or static, but it's probably because of the amount of bytes for each thing. So they are mapping the register thing there with the other class. I'm gonna go back. This is another thing that is confusing I have to review, which is right-hand side addresses. So right-hand side is the data, and left RHS values are data, and left ALHS values are addresses. And then there's some variations of that is kind of confusing. But this one is when you have an address of an RHS value. So you temporarily create an address for representing some data, so you can pass the ownership of the data to something else, as far as I understand. But it is very confusing. So let me go back here. So initializing with these objects, blah, blah, blah. Elf is an assembly generator, I think, from what I remember from other projects. This is LLVM wraps CLang modules inside a COF, ELF, or Mac O container. So wrap CLang modules inside. So it probably generates a container using these things that are related to. Let me ask ChatGPT, but I'm pretty sure that they are related to assembly. Three different formats used for executable and object files on various operating systems. Each of these formats serves as a container for organizing and storing executable code, data, symbols, and other information necessary for a program to be executed or linked. Overview. COF is an object file format originally developed by Unix system is commonly used on systems based on Microsoft Windows operating systems. File includes. So it's just the information for how to read the file. Is a standard file format for executables, object codes, blah blah blah. Yeah, so it's the file format. So this wraps the CLang modules inside of this file format. Turn an AST consumer that can be chained with a PSH generator that produces a wrapper file format that also contains full debug info. And this is the stuff that I was looking at. So this is the thing that I wanna. So it's creating this special hash map to map this writer with the class. Implements write operations for a raw pass-through PSH container. I think I'm starting to understand a little bit. So there's different variations. It's probably the same pattern that the Pure.js thing would use, where you create an abstraction syntax class that's gonna have the template implementation of the thing, and then the other ones are gonna inherit and specialize. So this is the raw one. So it has the format. So based on the format, you know what kind of class you're gonna store on the map. So you're mapping the string that has the type of which kind of writer it is, and then that writer is going to be used to the type's going to be used to determine what kind of metadata for the file you're going to put the thing inside. I think that's what's going on. So this is probably used on the later parts, I assume. This abstract interface provides operations for creating containers for serialized ASTs for compiled headers and CLang modules. Turn AST consumer that can be chained with a PSH, blah blah blah. So I think I understand. I'm gonna move on to the other functions. And this is probably the other one writes, this reads. I think that's intuitive. I have to be careful to not get caught up on the details now. I think I already spent too much time on the details. I should have gone faster. It's just that there's so many things and I want to understand how what each thing is doing. Initialize target infos. The main program should call this a function if it wants access to all available targets that all of them is configured to support. Is legal for a client to make multiple calls to this function. The main program should call this function if it wants access to all available targets machines that all of them is configured to support. It is legal for a client to make multiple calls to this function. I guess it calls this thing. So it just defines the target name. What is the target name? There's a lot of things here that are weird, like this. I think that's gonna be hard to understand what's going on. So I'm just gonna ask ChatGPT. With time, I'm gonna think about different strategies to search for these things. Expansion, blah blah blah. Inside the CLang project is preprocessor macro that performs string concatenation. Expansion. Token token pasting operator in the CPU processor. Hmm. I assume it's from C. So I guess this is related to selecting architectures. There's another thing that I'm kind of confused by, but I assume that the architecture is going to be based on the operational system. I think that the architecture is based off the operational system, and because the instruction set architecture is from the operational system to the hardware. That's what I think. I'm gonna ask ChatGPT as well. Each is a component of the C programming language standard is not specific to CLang. So I didn't know you could use this. Interesting. Token pasting operator. I'm gonna search this later. I think it's operational system. Oh, underlying hardware. Oh, so it's defined by the hardware. Hmm. So it is defined by the hardware. So I guess this is just it's just spacing these things here. The spacing three different variables together to one thing. So it's defining this as this. And this is calling. So it's using this to create a function name, I think. It's gonna be based on the architecture. I'm not really sure if I understand exactly how this works. Initialize targets. Well, the main program should call this function if it wants access to all available target MC that all of them is configured to support. Target registry. So I guess it's the name of the registers. No, that doesn't make sense. So target registry. A registry allows targets to register themselves with LNV. Targets registers. But I don't understand. It's just gonna be the other ones. It's obviously not obviously, but it is making like a function. It's creating a custom name of the function that is gonna be available later. Should be. It's probably gonna be related to creating different registers based on whatever architecture you're supporting. But for diagnostics from argument parsing, so that we can output them using a well-formed diagnostic object. And this is probably the most interesting one. It passes two different lambdas. If our round trip of command line arguments by default, the round trip is enabled. In assert builds, this can be overwritten at runtime. I'm more interested in trying to understand how does it, at what points. I guess when you call the executable, it's just gonna parse the flags, but it's not gonna. Maybe I think you have to pass the file, probably. Yeah, you have to pass the file that you want to compile. So I wanna know at what point does it read the file. So assume that it's gonna read the file and then it's gonna store the information or the file object in some struct, one of the structs that it's gonna use later on to create the tokens and the abstract syntax tree. And this is the function that was passed there, the lambda function. That's gonna be this thing. Parse generate. So just calling this lambdas here. And access to the option info table, the up table. Class provides a layer of indirection, which allows option instance to be created lazily. In the common case, only a few options will be needed at runtime. Contains enough information to parse command lines without instantiating options while letting other parts, so the driver still use option instances where convenient. I'm not really sure if this is... Okay, the thing is that it might be related to the file, but I think it's more related to the flags you can pass. I assume that this is just gonna parse the strings into specific arguments. Contains args. So it doesn't really matter to me that much, as long as I understand what it is here. Blah blah blah. Parse file system args. But I'm not really sure if this is related to the file itself. That's the thing, it's gonna be kind of hard to... It's gonna take time for me to understand where exactly. Because the thing is, the file could be together with the other ones there, or it could be a separate thing. Instead of being the arguments, is like, I don't know, a separate, is view based on the logic here as a separate command from the arguments. The arguments could be just the flag variables that you pass. And because I don't want to spend a bunch of time looking at the function there, it's kind of confusing. And preprocessor arguments. It's not hard to understand the structure of everything, but just the small, like the details of the structs and the data, how it's going to be changing everything. So the only thing related to file system is this thing. But I don't think it's the name of the file itself. It's just different options. So yeah, assume that is not gonna read the file there. So maybe this is the thing that gets the path. I think it is the... Yeah, but I'm not really sure though. So it might be that the argv0 is the file name and the argv is the flags, are the flags. And maybe that's why they use this array ref here. I'm not really sure though. I should ask ChatGPT. It's a convenience function provided by LLVM for initializing all assembly parsers that LLVM is configured to support. It makes these parsers available via the LLVM target registry. So because LLVM can compile multiple different languages, I think that's why they do this. I'm not really sure though. It has to be based on this description here. Macro expansion, the function uses a macro named blah blah, iterates. The macro expands to call where target name is the name of the assembly parser. Initialization calls. The macro expansion results in a series of function calls to initialize each assembly parser. The assembly parser initialization function follows this naming convention is the name of the target architecture or platform associated with the assembly parser. So it's not so much for the different languages, I think. It's more related to different hardware architectures that are gonna have different functions that are gonna have different CLang functions that are used to create the registers for that architecture. I think that's what that. So it's just initializing all the options there in the beginning, I think. Choose all these different architectures. So I'm gonna ask. So because from G++, I know roughly how you do it, but I don't have a lot of experience running programs only with G++ because I'm using CMake, but from what I remember, you just call G++ and then you put the source files, and then you can pass flags that are gonna specify the path to libraries and other stuff like that. And then you pass the /o, which is gonna be the outputs of the files. So, but I'm not really sure if CLang is the same thing because I think G++ is another compiler. So I'm gonna ask GPT what is usually the commands used to run a C++ project or to compile a C++ project using CLang. I do think you have to pass the files, pass the file names. So I think that this is how it works. Like you pass the flags first, and the flags are gonna be. But I'm not really sure how does that work. Like there must be another main implementation. I guess this is gonna depend because it depends on the way. So in order to understand this, I have to look at the CMake, I think. This is the kind of the thing, and it is kind of confusing because there's two different versions that they make it available there. There's one where it's just the CLang project, and the other one, the one that I'm looking at right now, is a folder on LLVM project. But based on the response I got from on Discord, it seems that the separate one is the one that is like the official one, let's say, and this one is more like not official. It's just he said they're pretty much the same, but the separate one is the one that you should use probably. So there's these two different versions here, and this one is separate that they make it available there on the link on the repository. So I think that in order to understand, I have to look at the CMake, but that's the thing, because I assume that it's going to be a massive CMake list, because I'm trying to understand what is the function, like how do they build the final executable that is going to be responsible for the CLang, that is going to be the CLang executable, because that allows me to understand, will allow me to understand what function is being run, because I want to understand how this translation happens from the command line arguments that you pass to compile with CLang to how it's going to translate into this. Just based on the intuition, I think what's going to happen is that, and based on the ChatGPT response here, what's going to happen is that the flags are going to be are going to go into this thing here, and the file name is going to be this one. But I guess I have to. I think that on C, and this is the thing. This is the reason why there's I think there's another function that is going to call this function, because I think on C and C++, like you don't have to specify what's going to happen because it's always going to be the same. I think it's part of the language that is going to call the main function, which is the entry point for the executable, passing predefined argument types. And I don't think that these are the argument types. So that's the kind of confusion that I have. Uh, one is going to be an integer, which is how many things you have, and the other one is the strings. So this is what I want to understand. And I think it's going to be the driver or something like that. Each point for ceiling with drivers, front end. So I think the real main is on the drivers, and then they do something to structure the command line arguments and then pass to this other function. CLang driver is executable is responsible for invoking this one function internally. CLang driver acts as the front end to the CLang compiler, parsing command line arguments, setting up compilation options. Yeah, so this is what's happening. So I'm gonna ask ChatGPT if argv0 is the and I think this is the thing because the driver is going to be probably related to compiling and compiling multiple different files, I think. So when you have CMake is going to be just the abstraction that is, CMake is also built with C++. So it's just a language that you can use to put the abstraction so you don't have to specify all the source files and the header files you want to compile. So but if you replace all the code that CMake does, it's just going to be a massive string that specifies all the source files and header files, I think, the libraries to compile. So I think that the driver is probably going to be the thing that receives that as an input and then structures everything. And then it calls this function based on that. Based on that. But if that's the case, then like I think because based on what is here, you should, even if you want to compile multiple different files at the same time, it should be only one thing. So it wouldn't make a lot of sense that this is a file because there can be a situation where I have multiple different files. So maybe that's how it works because you can put everything on a const char pointer because it's just going to be a pointer to an array. So maybe it accepts more than one name, either one name or more on the argv0 argument. Based on here, you should run, like you should accept multiple different files, I think. It's typically used to represent the name of the program being invoked. It's the equivalent of v0 in the main function of. It's often such the name of the CLang executable itself or the name of the tool invoking the CLang frontend. To be compiled or passed as elements of the argv. So the argv is it's gonna contain the names. So it's gonna be more annoying because I'm gonna have to understand how this array graph works and how the other functions work. But maybe there's another. I'm gonna ask GPT as well. Because I think that this is the first main thing to understand is at what point do they read the files or create file objects. Because then I'm gonna understand. Then I'm gonna find where at what point are they looping over the file to parse everything. So I'm just gonna ask ChatGPT. Create file manager, create this. Create output file. Oh, but this is the output. So it's gonna be on the driver. Compilation process which is initiated by the CLang driver. And so I have to start on the driver to search for the real main, which is gonna be the main entry point. I think I'm gonna stop here and I'm gonna focus on the texting upstream. So I'm probably gonna do it for a couple of days. I'm gonna focus more on the text and continuing to build the graphics project that I'm building, but I'm gonna devote probably 1 hour a day or something like that to studying the CLang source code. So I'm not really sure when I'm gonna come back, but yeah, see you then.